Match each function equation to the graphed function with the same zeros. So this initial graph, we're trying to match up a function having the same zeros as the graphed function. So that means we need to know the zeros, or zeros, another name, another word for solutions. But in this case, they're also another name for x-intercepts, and that might be the most helpful definition um, to remind us what we're looking for. So for instance, this exponential function has an x-intercept right here. It crosses the x-axis at x equals 3. Let's go and list them all for the graphs because we can do this quickly. This one, and I shouldn't use the word cross, just touches. This graph touches the x-axis at positive 1 and at positive 4. So the second one has zeros at 1 and 4, and then this last one touches the x-axis at negative 2. Now these choices down here, we could of course set them equal to 0 and use the zero product property, factor where necessary to get all those solutions, but the simplest way is to use a graphing calculator, Desmos, or find a free one online, find an app that allows you to graph these. That's what I'm going to do. That will save us a ton of time. So if you're using a calculator like I am, you want to go to y equals in the top left corner, and let's type in this first choice, k of x equals x plus 3, and see where it crosses. X plus 3, it crosses at, looks like negative 3. Crosses there at negative 3, and you'll notice none of these others have an x-intercept of negative 3. If you're not certain where it crosses, so let's just say, especially since it's the first one, you're like, is that a decimals it crossing at? Remember the trick, and it can be used really easy on this one. Let's rewrite that as y equals x plus 3. To find the x-intercept, you just set y equal to 0 and solve for x. To solve this one for x, it's very simple. Some of the others, it's not as simple. But this one's simple, and we get negative 3. And again, that doesn't match any of these. So we're just going to cross that one out and move on to the next one. The next one is here, x cubed minus 3x squared plus x minus 3. This one should have up to 3 x-intercepts. So I'm guessing, well, let's just see. We have it typed in there, graph it. Yeah, this one up to 3, but it looks like 2 of them are imaginary. So it only has one x-intercept that we can see, or 1, 0, and we can pretty clearly see that it's at x equals positive 3. So that means it would go up here in the top box. And we have our first match. The next one, let's do this one the old-fashioned way. It's probably quicker. Rewrite it as y equals negative 4x minus 8. Replace the y with 0. Solve for x by adding 8 to both sides first, and then dividing both sides by negative 4, and we get negative 2. We do have our next match. All right, let's check the next one, x squared minus 4x plus 4. So let's go back to y equals x squared minus 4x minus 4. This one's only going to touch once. No, it touches twice. Let me make sure I typed that in right. I did not. That should be a plus 4, not a minus 4. Graph it. This should only touch once if I'm, yeah. And again, kind of tough to tell, but I could see that crosses at x equals positive 2, which is not one of our matches up here. It's got a 0 of 2, so we can mark this one out. Let's check the next one. The next one is x to the 4th minus x to the third. The hardest part is typing it in correctly. Graph it, and this one appears to cross at, this one does appear to cross at a couple of different decimals. Let me make sure I've typed that in right. X to the fourth minus x to the third. I don't have that one typed in even close to being right. I thought that was strange. This should be x squared. Some of you were probably thinking, what is he doing? Now let's graph it. This one appears to cross at 0 and positive 1. Yeah, and I think that's right. 0 and positive 1. But we see we have one that has zeros at 1 and 4, but there's no 0. So this one does not match up with any of them either. Got to have the same exact zeros. This one I'm guessing is going to cross at 1 and 4. I'm going to go and write it in. I'm that confident. But let's just verify that it does indeed have x-intercepts of 1 and 4. Clear that out. X squared minus 5x plus 4. And yes, we can see it crosses at positive 1, positive 4.